Welcome to the SmartTechCheck podcast, hosted by Mark Vina, your home for candid, insightful, and provocative conversations about the smart home automation, security, smartphones, PC and console gaming, and much more.
Hello, everyone. My name is Mark Vina, host of the SmartTechCheck podcast. Today is Thursday, July 13th, 2023. Software plays a crucial function in the semiconductor space. It enables efficient design and simulation of complex integrated circuits, enhances manufacturing processes, facilitates testing and quality control, enables firmware development for embedded systems, and empowers advanced data analysis. Software is the indispensable tool for innovation, productivity, and overall progress in the semiconductor industry. To discuss this crucial role of software in the semiconductor space, I'm joined by Clark Jarvis, Senior Staff Technical Marketer of IoT Compute at Infineon Technologies. Clark, welcome to the podcast. How are you?
Yeah, thank you, Mark. Welcome. Thank you for having me.
This is an incredibly important topic, and I really mean that very, very genuinely in the sense that whether it's an OEM, which obviously you have lots and lots of device partners at Infineon, or whether it's just a casual mainstream user who's using a product with Infineon technology and I always like to say that there's a lot of people using products with Infineon ingredients that they don't even know. And I think that's fine with Infineon, by the way, but you probably have Infineon in your household and you just don't even know it.
Oh, absolutely.
But the importance of software is so incredibly important, and it's just sometimes taken for granted, which is really unfair because without software, silicon really wouldn't be the groundbreaking capability it is in changing the products that we use every day in our lives. But before we do that, I want to go into a bit of your background because I always find that kind of really helpful to do. So let me bring the slide up on the screen and I'll give you a couple of moments to talk about Clark.
Yeah, absolutely. So I've been in the semiconductor industry, right? We talked a little bit about that. I've been in the semiconductor industry since college, right? So I earned a bachelor's and master's degree in electrical engineering from Texas A&M. But after that, I came in and I started off as an actual solution architect. So doing kind of very hardware specific stuff on IP, connectivity IP that was going into these devices. And around 2009, I had an opportunity to completely switch gears, and I moved over into a marketing role, which I never thought I would go into a kind of a technical marketing role, but I've absolutely loved it. And it's interesting because we're going to be talking about this kind of transition of how our industry or the industry of creating products has moved from kind of hardware centric to the importance of software. And I've seen that mirrored in my own career of starting off as this hardware focused software architect and then moving into a role where I was focused on hardware, enabling hardware. So I focused on development kits and showcasing the features of hardware, and software just started trickling in more and more and becoming more and more critical to the role as these technical marketers, to where now it's full. For the past 10 years, it's been full-time just development tools and runtime software and everything that's needed for these product creators to go create products, right? A lot of the people in your audience, right, they're going to be using these devices in their homes, but behind the scenes, somebody had to make that, right? And so it's all kind of about the journey that person experiences in creating that product. So at Infineon, I'm in Infineon now. I've been here for almost 2 years now, focusing also on the development tools, the runtime software. Specifically, there's a tool that we have. It's Modus Toolbox. If you look at most semiconductor companies, they're typically split between the kind of automotive side and the non-automotive side. And so that's where I've always lived, is that kind of non-automotive side. It's all the stuff that's going into your homes, going into IoT products, right? All the cool stuff that we get to experience on a daily basis.
Now, Clark, are you suggesting that someone who's an engineer, who's got a technical background like yourself, they can't make that kind of peacetime transition into marketing?
It is possible. Coming to the dark side is possible.
Oh boy, we could have a few conversations. I think that's such an entertaining observation because, believe it or not, it's hard for a marketing person who's been trained in marketing to go into engineering. But very often, some of the best marketers, come out of the engineering discipline. And of course, when you get into marketing, you start to get a bit more creative on the promises that technology can deliver. But that's an entirely different. That's an entirely different discussion. Let's go to our first topic, and this is kind of an interesting industry topic. How has the software ecosystem for semiconductor devices changed so drastically over the last 5 years? I mean, it's always been important.
Yeah.
Why has that ecosystem evolved over the past 5 years, in your view?
Yeah, even prior to that, there's been lots of changes. In the past 5 years, one of the major trends that I've seen happen with software ecosystems is really a focus on making sure that they're actually providing efficiency to that developer, right? The person creating the project has to be more efficient. So that'd be kind of that main theme that I would have for what has drastically changed. But I think it's interesting to look at kind of what are the driving factors behind what is causing these changes. Because from a software ecosystem perspective, while we try to be innovative, right? I always want to have some innovative feature or capability in the software products that I'm responsible for. It really is much more of a responsiveness to what types of products are being developed, how they're being developed, right? So I think we can talk about kind of that framework or that idea of what's being developed. And then also it's who's developing as well. And you see a shift in what is that profile, what does that actual embedded engineer look like? So I think those are two interesting aspects that we can dive into a little bit.
First, but let me just jump in here for a second here, because 5 years in the technology industry, that's like an almost like an eternity. Do you think that in the last 5 years you've had, well, it actually goes back to 2007, you've had the rise of smartphones, but back 5 years the smart home has taken off in a big way. We've had this, the smart home is really, when you think about it, a collection of IoT devices. I mean, you could define them in different ways, but how is that kind of impacted when we talk about the smart home and IoT devices? That smart home market has exploded over the last several years, and I think it'll even get, it'll gain even more tailwinds over time with the Matter initiative and other things that are happening. But can you talk just a bit about that?
Yeah, no, absolutely. And you even kind of referenced the iPhone, right? And the kind of, I did the smartphone, and that maybe predates that 5 years, but that was a first major transition that we saw, right? This idea of how I interact with a product, right? And having this nice screen and interacting with the screen. And we saw like almost an explosion of, right? Everything had a screen, right? I'm going to put a screen on my toaster oven and everything else. And I think where we're at now is there's another little bit of a shift. I mean, graphics and displays and interfaces are still critically important, but I think we're putting a little bit more intelligence into how we interact with devices. And that's what's happening over the past 5 years with IoT and more devices being able to communicate and talk without us even interacting with them. And you're getting down into devices having more intelligent interfaces, right? So I can walk up to something and converse with it. I can communicate with it, very intuitive, right? Whether it's through radar or the IoT backend systems, right? Things are a lot more intelligent in terms of the product. Well, not this is driven by IoT, by machine learning, even by COVID, right? The impacts that COVID had on us, and this, not wanting to go in and touch everything, but have products that just almost anticipate how we want to interact with them. And right, that's the type of products that we're seeing.
Yeah.
And so we have ecosystems now, the ecosystems that we're using to develop those products now have to address those use cases and how they work, right? So you mentioned like Matter, right? And making sure that I can tie into these standardized protocols and interfaces and use security and things like that.
Well, and let's face it, you look at what Apple did with Apple Silicon, and while Apple Silicon, even at an architectural level, you got to give credit for Apple for jumping into the silicon business a few years ago. So the silicon would not get would not be as optimized and high performance oriented as it could be unless the software was so optimized to work with the silicon itself. And so, it almost kind of took Apple. Hey, look what happens when we control the ecosystem, and we bring software and our know-how on software, our newfound know-how on semiconductors. We bring that together, and it creates this kind of incredible synergy that you simply can't get if everything is off the shelf. So, it's a very interesting dynamic. But let's jump into the relationship between hardware and software, and let's kind of move the camera back to what's going on today. So talk to and you can cite a few examples of Infineon solutions that, hey, here's a really good example of when the hardware and software comes together, you really get a very compelling solution that solves real life problems.
Yeah. And I think, what's interesting about the way we're wording this statement here, right? There's no doubt that software is becoming more and more important. And I think one thing that's been very obvious for me is when we're working with people who are making these products, we see much more of that software engineer, right? The guy making the software, he's now involved in these early on discussions. He's the one that's helping to make these decisions because we see how critical software is in the development of the product. But I think you're right? Hardware is always going to be critical, right? You're always going to have a discussion on the speeds and feeds, right? How many, megahertz can I get out of this? But what I really like about this particular question is it's that and in all caps, right? Because the value is not that hardware is important and software is important, but it's that hardware and software together. That's what's important, and that's what's making such a major impact in the way we develop products and the products that are out there. One example that I have is on the Infineon microcontrollers. We have this capacitive touch technology, right? This ability to have these capacitive touch interfaces where I can go in and work with it. And from a hardware perspective, I don't want to discount, right, the coolness of that hardware. I mean, there's literally decades worth of research and development into that hardware. Like, you gotta peel it back though. It's really just a really smart analog IP, right? That's what it is. And it's got some cool capabilities, but when I put on the software, right, the actual drivers and the middleware and the ability to use that hardware and software, so I can walk up and say, hey, I'm going to detect a swipe or a slide or a rotation. That's where those things just become so powerful in being able to create a product. And from a developer's perspective, I don't have to worry about trying to reinvent the wheel. I don't have to write the software and figure out how to make that hardware do what it's supposed to do. I've got that software that accompanies it, those drivers and those higher level middlewares built on top of it that let me differentiate it and really make something out of it.
Well, and talk a little bit about the fact that, from a offering standpoint, semiconductor companies, they win because God knows I worked for a major one in Synaptics for a long time. You win a design on a spec, but very often you win the design, and guess what? That customer comes back to you and says, that spec is now changed a little bit. Silicon is still not at the point where you can just go back to the fab and, okay, we're going to tweak it a little bit. There's the silicon from a development lifecycle standpoint, the runways are very long. So you have to depend on software, especially at the firmware level, to be able to re-optimize different aspects of the silicon so it can work in an OEM device product spec that may have changed since you actually win the business. So talk a little bit about the importance of that.
Yeah, because product requirements are always changing, right? I mean, especially if you don't get it out in the right amount of time, right, then the requirements change. You got to add more to it. And that is true, right? Software can do a lot to help extend the capabilities of the hardware. And we've seen that. I will say, though, it is interesting, though, because I do see a little bit more of a shift, right? That there was kind of a mentality of saying, I've done the hardware. We've met all the use cases for the hardware. Throw it over the wall to the software guy and say, "Hey, go add the software." That software just put it on top of it. You can do it in software, right? And we do see even more of a shift of that software guy being involved more early on as well, because software can make or break that hardware, right? I mean, I will take a use case as well of like a low power use case, right, where I've designed the hardware. And I've got certain power metrics I need to measure. This thing's got to live on a battery for months at a time. And whether or not the hardware is capable of it, software's where you're going to make that happen, right? Being able to know when to put the device down into low power states and transition, turn different things on or off. Software is really what's going to allow you to take advantage of those hardware capabilities, right? And you're absolutely right, though, as product requirements change, right? And different things get added. I can go in and I can extend quite a bit of that with software. I think where we need to make sure we have a good support and the way we make these products successful is being able to make sure a software engineer can do that very efficiently, right? They're going to have all of those middleware, those building blocks that they create these software pieces that are readily available for them to pick up and use and then to go differentiate on.
Now, Clark, before we hit our next topic, do you find that Infineon, which is a very successful company, and it's got global reach, plays in multiple product categories, ranging from consumer products to IoT products to enterprise products to automotive. And I've probably missed 9 other categories. Do you find that a lot of the partners that you work with, and you don't have to name names, that they claim to have expertise in software themselves, but you find that when you're partnering with them, Infineon brings a lot of software resources to the table and makes the partner better. Now, that's not to say that your partners don't have expertise. They do, but it's a very competitive world. Yeah. When a company is developing a product, they look at the bottom line. They can only have so many people working on a project to make it profitable over time. They got to keep expenses as low as possible. But do you find that from a software expertise standpoint, you're very often you're helping your partners with their software expertise? They have software expertise, but you're actually making it better because of the relationship that your engineering teams have on the software side.
Yeah, no, I do, but I also say it's the other way as well, right? That works both ways, and I think it's important for us to understand where is the domain expertise in a particular aspect of software, right? Infineon, at the end of the day, we are a silicon vendor, right? We sell chips. That's really what we're trying to drive in terms of having a successful product. And we have expertise, right? We put a lot of investment and in research and in kind of compelling features and capabilities into the hardware, and we know that hardware very well. So when we shift our attention to software, we look at the different domains even within software. And if I'm talking about those drivers, right, then that ability to make that hardware do what the hardware is capable and designed to do, then we certainly have. Infineon has that expertise to do that, right? We know that IP, we know how that hardware, we know how to take advantage of the multiple cores that are in the device, to the low power features, those compelling hardware features like capacitive sensing and connectivity solutions. We know how to make those work at a very optimal level. And so we see that kind of domain where we will focus on that and we provide the enablement there. But then if we start looking beyond that, as the software development kind of breaks a little bit, is distant a little further away from the device itself, you start looking at connectivity stacks and being able to connect to the cloud and working with graphics displays and things like that. Well, then that shift of expertise is going to some of these partners that have invested just as much time and effort that we have on our silicon. They've invested that same amount of time into kind of their domain of expertise. And so you've got to find a way to create a very compelling symbiotic relationship with those partners to say, hey, we can provide these compelling features for the devices and the drivers and really make it do what it's needing to do, but still be able to utilize your expertise and the amount of resources and investments that that partner or that provider for that higher level middleware and stacks have made into where they have their expertise.
Yeah, so let's drill down on that question a bit. This is our last topic about specifically how Infineon works with its software partners to leverage your expertise to include software in all of its product solutions. Because again, it's probably very difficult to find a Infineon solution does not have some type of software component.
Oh yeah, absolutely.
In fact, I'm sure it's impossible. So let's address this topic from your perspective.
Yeah. So, I mean, what we've seen, we talked about kind of this transition of a software ecosystem where kind of this expectation of a developer is that they have a lot of things that are provided for them, right? Because if you look at different products that they're creating, there's a lot of reuse in that, right? I'm going to be able to reuse kind of the base drivers and how I make the chip itself, right? The silicon chip itself do things. And even down to, we're talking about IoT devices, right? That there's a common connection that's going to get me connected to the cloud. It's going to be get me connected either through Bluetooth or Wi-Fi, right? There's sort of a lot of very common components. And that's going to be kind of universal across a huge range of products that people are developing or making. And so we want to make sure that all those building blocks are there for them. But then we talked earlier about that expertise, right? There are these middleware providers, software providers that have expertise, whether it's in graphics and things. And we want to make sure that it's easy for them to integrate that into their product, because that's what this is all about. That's what software ecosystems and enablement is all about, is about making sure that engineer is very efficient at building a product, right? Because if they can build a product faster, better, more features, they're going to have a more successful product. So the goal for us is now really to make sure that someone has a very good experience with being able to integrate these partner solutions. And we're moving away from, there used to be kind of an idea that says, okay, well, there's a partner out there, or there's a company out there that's got this really cool software piece. I'll take it, I'll inbound it, I'll take it, and I will modify it, and I, meaning like Infineon, will take it and we'll tweak it and we'll adjust it and we'll get it ready to work on our products, and then we'll kind of push it back out. And it works, but it's not scalable, right? We need to be able to offer a whole wide range of these pieces. And so where I see the industry heading in terms of these silicon vendors and working with ecosystem partners is the ability for the partner themselves to be able to deliver content, to be able to own their own content, and have it still work seamlessly with products like Modus Toolbox. So we have a specific initiative with Infineon called Modus Toolbox and Friends, where these software providers can actually follow a designated framework, right? We've got documentation and detail saying you just add these few little files to your solution, and we can now have it integrate directly into Modus Toolbox. So then it's like checkboxes, right? Yeah, I want that. I want that. And have that software come directly into the developer's working environment. So it makes it just...
No, that's gonna has to have an incredible impact on scalability.
Yep.
Not just scalability, but the ability, since silicon does change, the software can scale with that, and it makes your time to market cycle that much more efficient.
Yep, and the responsiveness too, right? I mean, in the past where we had to rely on the silicon vendor to kind of inbound and regurgitate the stuff, if there was a bug fix or something, especially when we're talking a lot of security issues that may impact real products, right? That's major things. That ability for that expertise owner, right? That domain expertise that knows their software, they know that stuff, to be able to make those updates and have it just automatically work and not rely on a full circle, like, okay, well, let us make the tweaks to it and get it back out. Right, That's huge in creating, secure, maintainable products.
Well, before we wrap it up here, any closing thoughts, Clark, that you might want to just close the podcast with?
Not too much. I mean, we see a lot of exciting things happening with the products that we get to experience on a daily basis. So it's kind of fun to have a conversation like this, to look at what's kind of one step behind that, right? What's kind of happening behind the scenes? What does it take to actually go in and create these products, and kind of see a shift from focusing on, the speeds and feeds, the hardware stuff, to just the importance that software brings to being able to develop a product and to be able to successfully develop a product, right? Because it's all about being able to develop it quickly, to be able to get it out there. Anything we can do to create more intuitive products. Infineon takes a very big stance on trying to drive decarbonization, digitalization, right? Trying to make our world a better place. And it may seem strange, but we can do so much of that through the products that we're creating, how we're creating, the efficiency in which we're creating them. That's to me what's kind of exciting about the products that are coming out now.
Well, Clark, that's a great way to end the podcast. I really do appreciate your time. Thanks for taking the time to join me for today's podcast. For our viewing and listening audience, thanks for making the Smart Tech Check podcast part of your day or commute. Please make sure that you hit the like and subscribe buttons at the end of today's podcast, or use these on-screen QR codes to connect with me. You can also follow me on Twitter at @MarkVinaTechGuy. And until next time, have a great week. And Clark, thanks again for your time.
Mark, thank you very much. Thank you, everyone.